Hi Chemistry, Mrs. KJ here, and this is the Unit 3 Reactions of Metals Lab Report. Keywords and pronunciations. It does say turn in the lab. You do not need to turn anything in. Just when you are done with all of the Educanon videos, there's more than one. So when done with all videos, just let me know. So send Mrs. KJ an email telling her you are done, because that way I can put it in the grade book. All right, key words and pronunciations. Chemical change, a change that results in the formation of one or more new substances. Physical change, change to a substance that does not alter its chemical composition. So it's the same thing before and after the reaction. So for example, if you fold a piece of paper, it's still paper. That would be a physical change. If you melt ice, well, when it's ice, it's H2O. When it's liquid, it's H2O. It's the same substance. It's a physical change. And remember, all phase changes are physical. So boiling, melting, condensing, freezing, those are all physical changes. Laboratory, reaction of metals 1. Reactions involving metals give insight into how products form. In this laboratory, you will perform an experiment that involves mixing reactants that contain metal atoms. You will observe the formation of new substances from some of these mixtures. Goals: observe physical and chemical properties of transition metal ions in solutions. Observe the results of mixing ammonia and hydrochloric acid with metal ions. Compare the reactions of transition metal ions with those of other metal ions. So we're going to be putting some chemicals together and comparing them. Metals share distinct properties. Metals are solids, except mercury, which is liquid at room temperature. They are malleable, so malleable means you can bend them, and ductile. Ductile meaning they can be hammered into different shapes and drawn out into wires. And they are good conductors of electricity. Many metals are shiny and also are good conductors of heat. These properties may vary with individual metals, but for the most part, these are the properties that metals share. Properties of metals result in the many ways in which they can be used. Conductivity of heat, malleability, so you can bend it, and ductility, you can make it into a wire, make metals versatile enough to use as the basis for many machined objects. And this person is welding two metals together. Chemical reactions with metals may create some interesting results. Chemical reactions occur when two substances react and a new substance is formed. Think about a piece of burnt toast. You turn the setting on your toaster up too high, and that piece of bread you put in turns into a black, burned piece of toast. You can't turn that toast back into fresh bread. A new substance is created on that burnt toast. The deposits of carbon on the outside. So the black ash is actually carbon. In this virtual lab, you'll be mixing substances and creating new substances. The substances you create will form precipitates. A precipitate is a solid that forms when two liquids are mixed and they chemically react. So you pour together two liquids and boom, you get a solid. Be on the lookout for new solid substances that may form. Chemical reactions may produce precipitates or color change. All right, let's watch a video of a precipitate. And so we have two clear liquids. We have lead nitrate, and it's poured into potassium iodide. So you can see they already have the clear liquid in here, and you can watch they're adding a little bit more of the clear liquid. The other clear liquid, which is the lead nitrate, you can see it was clear, and then boom! As soon as those two clear liquids touched, look what happened. It made a precipitate of lead iodide. So a precipitate, a lot of times, kind of looks like magic. We put two clear liquids together, and look at what I got. Not only a distinct color change, but I have chunks of a solid. So this is an example of what a precipitate is. You put two liquids together, they have a chemical reaction, and they make chunky solids. All right. The precipitate that results from chemical reactions with metals have many uses. As you work through the steps in the virtual lab, you will find that many colorful precipitates are formed. these colorful substances are often used as pigments for paints and even as indicators for chemistry experiments. Think of the results of the chemical reactions you observe as useful pigments with many applications. So pigments meaning to give color. So here, cobalt, the metal cobalt, makes these bottles that really pretty blue color. And that's why if you're into art, you might have heard of cobalt blue. That's why. It's from the actual element cobalt. And then we also have cobalt, depending what else you do with it, can also make a green color to glass. So observe the reactivity of some metals by working in the virtual lab. All right, so we're going to go ahead and get started with that. And the first thing that we're going to do is we're going to fill in a data table. So we have 4 chemicals across the top: potassium nitrate, calcium nitrate, NH4VO3, ammonium vanadate, and manganese sulfate. And we're going to mix them with this. This right here is actually ammonia. You may have used that before in cleaning. And HCl, so it's a lowercase l, not a capital I, HCl is called hydrochloric acid. And then we have one row which is the control. So the control is what we compare our results to. So all that's going to be in this is the original chemical. So you can see how these match? Because we want to say, okay, if I just have the chemical by itself, what does that look like? And then we can compare this row to these 2 rows to see if a chemical reaction occurred. To the lab. So I have all of our chemicals going across the top. And I'm just going to add 10 drops of each. After I zoom out a little bit so it lets me. And next I'll do the calcium nitrate. And the ammonium vanadate. And the manganese sulfate. All right, so now we're going to do our first set of observations. So this is what the chemicals look like by themselves. So these are our control. All right, so we see that 3 of them normally are light blue, and that one, depending on your screen color, let's see if I can make it a little brighter, I would go with it's kind of brownish. If it looks a little pinkish on your screen, that's okay. Point is, we can tell that it's obviously different. So that's our control. And so I filled in our control row because remember, this is what we're going to compare the rest of our reactions to. So this is the normal. Okay, the control is the normal before we do anything else. All right, so we'll go back to our lab. All right, so what I did on pause is I just put the potassium nitrate, this KNO3, in all of row 1, in all of column 1. I put the calcium nitrate in all of column 2, the ammonium vanadate in all of column 3, and the manganese in all of column 4. Yeah, I skipped that row because we didn't need it. So now what we're going to do is we are going to add ammonia. Ammonia is a base, and we're going to add 10 drops. And I am going to stir it. And we are going to compare it. So this is what it looks like after I added the 2 chemicals. This is what it looked like before. Obviously there's less stuff in there. So we're looking specifically at the color for, would you say, if this one is a chemical and physical change, and what observation would we make? So I would say that it is still light clear blue. All right, let's do the next one. And I added ammonia to our calcium nitrate. Stir. And check the side view just to make sure. And what should we write for that observation? Same thing, light blue clear. All right, let's try some ammonium with the ammonium vanadate. And we'll mix. And we'll compare. So what are we going to write for this observation? Yep, doesn't look like it did anything. All right, now let's try the manganese sulfate with the ammonia. And we'll stir it. Whoa! Something happened. All right, so let's look at our side view. And hopefully I caught that side view fast enough that you could see that the dark brown sank to the bottom. That's another sign of a precipitate. All right, so for this observation, we need to look what color is the liquid, and the liquid is on top, and what color is the precipitate, which is the chunks that fell to the bottom. All right, so I would say light brown, clear liquid at the top, dark brown precipitate at the bottom. If it looks a little reddish on your screen, that's okay. The big thing is the darker colors on the bottom. All right, so now we're going to mix our chemicals with HCl. HCl is hydrochloric acid. And there we go. And we're going to do the bottom row now. So 10 drops in each. All right, I'm having a little bit of problems here. Hang on a second. Okay, I fixed it. So we're going to add our HCl with our potassium nitrate. And we are going to stir it. And what would we put for this observation? Yep, light, clear, blue. All right, now let's add some HCl to our calcium nitrate. And we will stir it. And we will make our observation. So what would your observation for the calcium and HCl be? Same thing. All right, now let's do our next chemical here. Add some HCl and stir it. Ooh, we definitely have something going on, right? All right, so what would you put for these observations? Remember, this is what it looked like if nothing happens. Okay, that's the same as the control. So that's what it started as. And, ooh, something else is happening. Did you notice that? Yeah, it started out as yellow, and now, what would you write down? Hopefully you can see that it's definitely greenish, and now it almost looks blue, doesn't it? Here's a blue one. So very cool. If you missed it, I'm going to do that one again. So this was our control, so let's just add it in here so we can see this one again. All right. So we're going to have to write a couple colors for this observation. So here's our second color. And then it turns to our third color, which is the same as down here. Isn't that really cool? All right, either way, this color is different than its original color. Doesn't matter that it's the same as all these other blues. This blue, it started out brown. We definitely have a chemical change. So let's write down our observations for this one. So bright yellow turned green, then turned light blue clear. And I put an exclamation point because, come on, that's what it really does in real life. That's pretty cool. How many things do you know? You pour two liquids together and it's like a little miniature rainbow. All right, we'll finish the rest in the next video.